Okay, let's work on finding the derivative of this function dy dx, or sometimes we say y prime, instead, just depending on which notation we're utilizing. Pretty complicated looking equation we're given in this case, but we'll walk through it step by step and make sure we're very clear as we go through it. All right, so kind of jumping right in here, we'll take a look. We notice in this first term we have a multiplication going on. So that's kind of indicating when we have two functions and there's a variable in each one of these, we're going to be approaching this using the product property. So I'm going to treat this first function as being y to the fourth power multiplied by a second function, we'll call it g, which is that e to the negative 5x. All right, for the product rule, let's map it out first and then we'll walk through it. We're going to have the derivative of our first function, f, multiplied by g, plus we leave f alone, and we're going to multiply by the derivative of g. All right, so one step at a time. First, the derivative of y to the fourth power. All right, derivative of y to the fourth power, we're going to use the power rule. We should get 4y to the third power, right? Bring the exponent down in front, reduce the exponent by 1. But we also have to be careful here because we're doing implicit differentiation. What we need to do is we are taking the derivative of our variable y with respect to x. So next to this, we need to multiply by a dy dx. And I'll try to highlight exactly when we do that. Next, we want to copy down our second function, g. So our second function, we can just write multiplied by e to the negative 5x power. Continuing on with our product rule, we want to copy down f. So that's y to the fourth power. Then that's going to get multiplied by the derivative of g. But notice this is kind of a little bit more complicated. It's not just e to the x power, it's e raised to the negative 5x power. So because we have a negative 5x up in the exponent of an exponential function, we're going to have to utilize the chain rule. So the chain rule tells us our outer function, the e to the power, we're going to take its derivative first, which is again going to be e to the negative 5x power. All right, you take the derivative of the outer function, like an e to the u, which is just e to the u, and you leave the inner function alone initially, but then we have to multiply by the derivative of the inner function. So the derivative of negative 5x is going to be negative 5x to the 0 power, or negative 5. All right, because we're taking the derivative of negative 5x, x was our variable. What we could do is we could put a dx next to this. All right, but we typically don't do that because our variable x, taking the derivative with respect to x, dx over dx makes the same thing as a 1. And we typically don't write multiplied by 1 next to it. So I'm going to get rid of that. And let's move on to our next term. So as we take a look at our next term, negative 7x to the 8th power, this is going to be another power rule where we're going to bring the 8 down in front, multiply it by the negative 7, so negative 56. X to the new exponent here is going to be 8 minus 1, makes 7 for our new exponent. Again, our variable is x, so we don't need to put a dx next to this. We'll just leave that 1 off. Moving on to our next term, we have negative y to the 10th power. So again, power rule says that 10 comes down in front. Keep the same variable and reduce the variable or the exponent by 1. So 10 minus 1 is going to make 9 for our new exponent. But again, we did take a derivative, so be careful. This gets multiplied by the derivative of our variable y with respect to x. So we get a dy dx with that term as well. All right, finally, looking over at the right-hand side, we have a negative 8, which works out, it's just a constant, so the derivative of a constant is going to be 0. All right, now that we've gotten to this point, what I'm going to try to do is highlight, we have these two terms that don't have a dy dx with them. So our end goal on this is to isolate the dy dx on one side by itself. So what I'm going to suggest we do next is move those terms to the other side. And I'm going to write these, hopefully you can make this out. I'm going to think of that negative 5 in the first one that's underlined as being out in front. So I'm going to go ahead and add 5y to the fourth e to the negative 5x power. we're going to add that to both sides. So over on the right-hand side, again, we're going to add 5, y to the 4th, e to the negative 5x. Then the other term that needs to move to the other side currently is negative 56 x to the 7th. So we're going to add 56 x to the 7th to the other side here as well. All right, what that does is on the left-hand side, we had a subtraction, that negative 5. We're also adding it. We had the negative 56. We're adding 56. So those make 0 on the left-hand side. Let's rewrite what we still have left over. All right, I'm going to kind of creatively rewrite this so we have the dy dx out in front, multiplied by 4y to the 3rd power, e to the negative 5x power. And then we also, what didn't get crossed out, we're going to have, I'll write the minus dy dx. You don't have to put this out in front, but I'm going to go ahead and do it. Then we had a 10 y to the 9th power. And then over on the right-hand side, as we move those two terms over, we'll end up with positive 5 y to the 4th, e to the negative 5x, plus 56 x to the 7th power. All right, so we've isolated all the terms that have dy dx on one side, all the terms that don't have a dy dx to the other side. And I've tried to highlight the dy dx exactly where they are, because the next thing we're going to do is go ahead and factor out. We're going to consider that a common factor for each one of these terms on the left-hand side. So if we remove that or factor it out, we're going to be left with 4y to the 3rd, e to the negative 5x, minus, again, the dy dx comes out, 10y to the 9th, and bring down the right-hand side. Okay, so just copying down these terms from the right-hand side. Not much work going on, just bringing them along. All right, all that remains is our end goal is to get the dy dx on one side by itself. So currently it's being multiplied by that entire big set of parentheses. So we're going to divide both sides by what's in that set of parentheses. So divide by 4y cubed e to the negative 5x minus 10y to the 9th power. Do the exact same thing on the right-hand side. And then on the left-hand side, what you'll notice is we'll be able to go ahead and cancel out. We have a common factor between numerator and denominator. So the same thing, numerator and denominator makes a 1. So that'll eliminate itself, and we'll be left with just dy dx on the left-hand side. So we've accomplished finding the derivative. Now we do have x's and y's on the right-hand side, but that's okay. So here is our derivative, this entire mess that's on the right-hand side. I chose not to rewrite it without negative exponents. The simplifying down, we really can't do any simplifying down because we can't factor out common factors that'll be the same between numerator and denominator over on the right-hand side. So I hope this helps out as you're working on implicit differentiation. Again, writing out exactly which rules you're going to be utilizing goes a long ways as far as planning out the process that you're going to go through. Like what I did up top when I wrote out the product rule. Makes a lot more sense as you're getting used to implicit differentiation. So good luck as you're working on these.